I'll just change the color.
Okay, so next lecture is on limiting reactants, which is also known as limiting reagents. All right, so we'll use those terms interchangeably. Don't get confused. So during chemical reactions, when one of the reactants is used up, the reaction stops. And generally speaking, in pretty much every single chemical reaction, this is the case. Okay? One of the chemical runs out, it's completely used up, and is therefore the limiting reactant. Okay? And the one that's not used up is called the excess reagent or reactant. All right, so if quantities are given about both reactants in a problem, this is a limiting reactant problem. Okay, we've been dealing so far with, okay, we have X number of grams of chemical D, whatever it is. Okay, we only have one mass, one quantity. Okay, in limiting reactant problems, we're going to have two different quantities given. Okay, so we'll have a given quantity for A and a given quantity for B. Okay, and that's how we'll know that this is a limiting reactant problem. All right, so we need to first determine what the limiting reactant is. All right, and once we do that, we'll be able to use the limiting reactant just like we have in regular stoichiometry problems to solve for the amount of product that is produced.
That's a nice arrow.
That's a real nice arrow. The limiting reactant, it's a nice accent. I never know if I'm going to say reactant or reagent. Okay, anyway, the limiting reactant limits how much product can be formed. So for example, we were talking about tricycles the other day.
We were?
I was.
I wasn't.
Okay. So anyway, in a tricycle you need one frame and let's say just say 3 wheels to make a tricycle.
That would make a tricycle.
Okay. We'll just leave it at that. Make it really simple. So if I had, let's say, 2 frames and 17 wheels.
Oh, that's forcing it. How about 5 wheels?
No, 17 wheels.
Okay.
The maximum number of tricycles that I could make is 2.
Oh no, what is that?
Stop touching the board.
I'm sorry. I'm sorry.
So,
I gotta do that.
to recap, if I had 2 frames and 17 wheels, the minimum number of tricycles that I could make is 2. Okay? And the frame limits the amount of tricycles that I can produce. Okay? If I had 17 wheels, I could make 5 tricycles, but with only 2 frames, I can make 2. All right? So that's basically what a limiting reactant or limiting reagent is. Next slide. So, steps, because we all love steps.
I do.
Steps are awesome. All right, so start with the first reactant, convert it to moles. So whatever's given to you first in the problem, start with that, convert it to moles.
It already is moles?
If it's already in moles,
Yay.
Sweet. That's one less thing that you have to do. Step 2, convert the second reactant to moles. If that's already in moles,
Yay.
yay. You move right on to step 3. Now, you should know how to convert to moles. We've talked about it a lot. If you don't, bang your head against the wall a couple times. Go see Herzog or Kleinschmidt and learn how to do it.
Or
Okay.
read your book.
Read your book. All right, so step 3. Take the moles of the first chemical, all right, so what we got from number 1, and convert it to moles of the second using the mole ratio. Okay, mole ratio, nothing new. We know how to do the mole ratio. All right, and this is how much of the second reactant is needed to fully react with the first reactant. Okay, this is kind of tough to understand, but when we do it, it'll be a lot easier. Okay, so write this down, look at it a couple times, reread it 3 or 4 times, however many, get a general idea of what's going on, and then when we actually do this, okay, it'll
It makes sense.
It'll make a lot more sense. Okay.
But have these steps right with you, right next to you when you do these problems. You even have to take it out of your notebook. Do that.
Word.
So you can look at them while you're doing it.
Word. All right. So then we're going to compare the step 3 value with the step 2 value. Okay. And if the moles of the second reactant is smaller in step 2, then the first reactant is limiting. Okay, because that will be used up first. If the second reactant is larger in step 3, then the second reactant is the limiting reactant. Once again, a lot of words, it's a lot easier to see.
Yeah. Once you see a couple problems done, you're saying, "Oh, this is so easy."
All right, so let's go ahead and jump right into an example. All right, so This is a reaction, the combustion of ethene.
Yeah.
Ethene. All right. So if we have 2.70 moles of ethene, that's reacted with 6.30 moles of O2, we want to identify the limiting reactant or the limiting reagent. All right. Which one's going to be used up first? Okay. Now step one. Oh, rubbish. So step one was to convert the first chemical to moles. Guess what? Already in moles. Okay. So these two quantities here, the moles of ethene and the moles of oxygen, this is what's available to us. Okay? This is what's available. You want to write available? Just
Where?
underneath these. Just write available. All right, so this is what we have. This is what is available to us to use. All right, so steps 1 and 2 are already done. All right, so step 3 is to take the moles of the first chemical.
So we're going to say this is the first one. I'm just going to label that A, and I'm going to label this one B.
Why don't you do 1 and 2? First and second. It's a lot easier.
Okay, I'll put 1 and 2.
All right, so we're going to take moles of 1 in this case, the ethene, 2.7.
Oh my God.
It's Friday. Oh my God, Herzog.
Okay, I'm sorry. All right, here we go. 2.70
Moles of
C2H4.
Okay, and we're going to use the mole ratio, and we're going to convert that to moles of O2.
Okay, so let's see. It's going to be 1 mole of C2H4 on the bottom and 3 moles of O2 on top.
All right, so this is the mole ratio.
Multiplied by 3, and I should have about 8.10 moles of O2.
Okay, now this right here, this 8.10 moles of O2, that is what is needed in order to fully react that 2.70 moles of C2H4. Okay? So, the question we need to ask ourselves is, do we have enough available to cover what is needed?
No.
Okay, so think about it like money. All right, so I have $6.30 available. Okay, but I need $8.10 to pay my bill. Do I have enough? And the answer is no.
You ain't gonna get it.
Okay, I'm not going to be able to get there. So that tells us that O2 is the limiting reagent. Okay?
Did I spell it right?
Gent. Like gentleman. But, yeah.
Okay.
All right? So since I don't have enough O2 available to cover what is needed, that makes it the limiting reagent.
Again, what we're calculating right here, when you calculate from moles of C2H4 to moles of O2, this is what you actually need, again, to fully react with this 2.70 moles. And we need 8.10, but what's given in the reaction is 6.3. Since we don't have enough, that means that the oxygen is the limiting reactant, or limiting reagent.
Boom. Next slide.
Next.
All right, so same problem. Identify the limiting reagent, but instead of having moles to start with, we have grams. Okay, let's do 1 and 2 again. Put the 1 and 2 at the
Okay,
top.
well, it's Friday.
Friday.
I hate Fridays.
I do too.
Actually, I like them. Okay, I hate them.
Black.
I'm boring today.
Okay.
All right, I'll pick fuchsia.
Fuchsia. All right, so we're going to convert each of these to moles. So chemical number 1, we're going to convert to moles using the molar mass.
Chemical at 1, so you take 5.00 moles, grams of magnesium, and to get 2 moles, you use the atomic mass, which we have 1 mole of magnesium on top. It should be 24.3 grams of magnesium on the bottom. Adios grams.
And that should give us 0.206 moles of magnesium.
0.06 moles of magnesium.
Okay, now step 2.
Horrible.
It's all right. Step 2, we're going to convert the grams of hydrochloric acid to moles.
So we're going to 6.00 grams of, it looks like,
It's fine.
0 HC.
It's Friday, Herzog. I want to get out of here.
I know, all right. 1 mole of HCl and 36.5, I think.
Yep.
Sure. That's what it is now, 'cause that's what I wrote down.
It's right.
I get
Okay.
0.164
Moles.
moles of
HCl.
HCl.
Okay, so this is what is available to us.
So this is what we have.
All right, so 0.206 and 0.164, though, that is what we have.
No, get rid of that. Yeah, so again, this is what we have.
All right, for each of these.
Have available to us.
Right. Okay, so this is what is available. All right, so step 3 is to take the first chemical, the number of moles with the first chemical. I mixed it up. I did it a different way. I did the second chemical. But that's all right. Go ahead, just do it. Don't do it that way. Don't do it that way. Do it the other way.
Okay. Well,
We're fighting.
And we're back. Okay.
Okay.
So
Herzog won the fight, so we're going to start with
0.206
0.26 moles of
moles
Mg.
magnesium.
Magnesium.
Convert it to moles of what the second chemical.
HCl.
So use the mole ratio.
All right, so that's
Be
2 moles HCl
HCl.
over 1 mole Mg,
Can't see cancel.
All right.
So that.
and that comes out to 0.412. And if you don't believe me, check it out.
Okay.
0.206 times 2. Boop. See, I win.
Perfect. Alrighty. Go away.
All right. So this is what is needed. Okay. So we need 0.412 moles of HCl, but we have 0.164. So the question we need to ask ourselves is, do we have enough? And the answer to that is no. And therefore HCl is limiting.
Okay. Horrible.
It's fine.
Okay.
They can read it.
Okay.
They're pretty smart. Okay, so we're going to do a little application problem here. All right, so this question asks how many grams of MgCl2, how many grams of a product, magnesium chloride, is produced from a reaction with 50.6 grams of magnesium hydroxide and 45 grams of hydrochloric acid. Okay, so this is what we were talking about before. All right, you can see that there's 2 different masses here. So the first step that we have to do is find the limiting reagent. And then once we find the limiting reagent, we can use that to convert to the mass of MgCl2. All right, so let's get it started here, Herzog.
So we have, let's see, what? Yeah, you could write. All right, so what we're going to do is, again, we know this is a limiting react. What the heck is that? I don't know. I should write it. All right, so what we have is, since we, okay, all right, it's not working.
You
out.
talk too.
Okay, I'll talk, I don't mind. Oh, since we have 50.6 grams of magnesium hydroxide, MgOH2, we're going to convert that to moles, because that's what we compare. We compare moles of everything. So we're going to say the molar mass is 58.3 grams of MgOH2 for every 1 mole of Mg. Leave me alone.
Man, we are on the struggle bus. Driving the struggle
and when
bus.
you divide, you get 0.868 moles of MgOH2. All right, so now I have
Same thing for HCl.
45.0
Grams.
grams of HCl. We already did the molar mass. We calculated that as 36.5 grams of HCl for every 1 mole of HCl. That cancels out, and I divide those 2 numbers, and I will get 1.23 moles of HCl.
Whoop, whoop.
Okay, now we take
Molar ratio.
0.868. Good enough. All right, I gotta fix that. Try fixing things and it just gets worse. 868. 8. There we go.
Like a special snow.
I'm special. MgOH2. And we gotta use the mole ratio to convert that to moles of our second chemical, which is HCl. So we're gonna use the 1 to 2 ratio. So 1 mole of MgOH2 goes on the bottom for 2
Mole,
moles
mole.
HCl. That cancels
What is
out
HCl?
It just didn't show up. And when we do that, we get
Okay.
1.74 moles of HCl. So this right here is what is needed. This right here is what's V half.
Do we have enough?
No.
No, we don't.
We don't have enough. So that means the HCl is the limiting reactant. I'm going to abbreviate that. Is that okay?
That's great.
That's perfect. So HCl is the limiting reactant. Now, when we do the problem, once you know what the limiting reactant is, you just use that information and then you solve the problem. So we want to know how many grams of MgCl2. So now, this is just like what you've been doing. Once you know what the limiting reactant is, you use that information because that actually limits how much of this is produced. So we're going from here to grams of MgCl2. So let's go ahead and
Do that.
solve this. So we have 45.0 grams of HCl, and I'm going to convert that to moles. So we already did that. Cheryl, go away. I should have took my email off. HCl for 36.5. Oh my God. I am awful today. I'll be better next week. Okay, now we need to use the mole ratio. So I put 1 mole of MgCl2 on top for every 2 moles of HCl. Right? That cancels out, and I have to multiply by the mass of MgCl2. So we put 1 mole of MgCl2 on the bottom. Adios. That cancels out. And the mass, which is 95.3 grams. Uh-oh. MgCl2. And that is the unit we want to be in. So we take 45 divided by 36.5 divided by 2 times 95.3, and we get our answer of 58.6 grams of MgCl2. And I'm done.
Woot woot. Happy Friday, everybody. Deuces.
Adios. Done?
Done.